In this video, we'll look at dilations, and the key questions for today will be how to determine the scale factor used and how to find the point of dilation or the center of dilation. So in this examples today, what we're going to have is the dilation, but the question will be, what was the scale factor used? Question number one. And then how to find the point of dilation. Where was the dilation from? First thing, we have to determine in our dilation which one is the pre-image and which one is the image. So I have two rectangles, and what the labels tell us COMB is the original shape and the prime is after. So that means that the image is smaller. So if the image is smaller, the scale factor has to be less than 1. Image is small or smaller. So the actual image after the transformation, this one is before. The bigger rectangle is the original or pre-image. In order to determine the scale factor, what we need to do is set up the ratio. Set up a ratio. And the ratio will be of the image to the original, to pre-image. So let's pick a side of the image. Let's say CB. That one is 2 units and OM is 2 units. So let's say CB prime to the corresponding side CB of the original. CB prime has 2 units and CB4 gives us the ratio of 1, 2. That means that CB divided by 2 gives us the image 2. 4 divided by 2 is 2. So the image is half size. Or we can check the length of the image CO with primes over CO original, which is 3 to 6, and 3 to 6 reduces to a half as well. So that confirms that our scale factor is 1/2. K equals 1/2. The image is half size of the original shape. Second question, how to find the point of dilation? To find the point of dilation, we need to see where the vertices will connect by tracing these connecting segments from each corresponding vertex. And we're not just estimating, we're going to use the exact count. So let's say from C to C prime, I have to go 1, 2, 3, 4, 5 over 1. So I repeat that. 1, 2, 3, 4, 5 over 1. Place a point and then trace a segment. Focusing on B and B prime next. I go down 1, 2, 3 over 1. 1, 2, 3 over 1. Seems like this point right here will be our dilation center, but we need to check that by connecting all the vertices and making sure that the count works. So for O to O prime, I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. That works. And then from M to M prime, I go 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. That works. So that confirms the location 3, 0 as my point of dilation. So scale factor is 1/2 and point of dilation is 3, 0. To get through these steps one more time, we have two figures. The labels help us determine which is the pre-image, which is the image. Primes means that this is what the image is after the dilation of the original triangle A and C, or based on our directions, it's labeled CAN. So CAN, triangle CAN is dilated to a C prime, A prime, N prime. So this is our dilation, which is bigger, right? Bigger means scale factor used was greater than 1. So here, image is bigger. Scale factor is bigger than 1. So that is something to look forward. We have the original shape, image is bigger. It means that I have to get the scale factor bigger than 1. Let's see what it is. To determine the scale factor, set up a proportion. So proportion or ratio. A ratio of image to original. The size you pick. So the image CA, let's say, something that is quick to read, is related to CA as 3 to 2. 3 to 2 or 1.5. Let's check another side. Let's say this one can be checked as 1, 2, 3, 4, 5, 6. So C prime, N prime, related to Cn. So image C prime, N prime related to Cn as 6 to 4. 6 to 4 reduces to 3 over 2, which is again 1.5. So the scale factor is either 3 over 2 or 1.5. It can be as a fraction or it can be a decimal. To find the point of dilation, we need to see where the connection of the vertices are going to intersect. Using 1/3 for n prime, I have to repeat that 1/3. That's right here. From C, I have to go 3/3. You can go across this way, 3/3. And for A, 3/2, 3/2. We don't have the connection yet. So what that means is I need to repeat it again. So 1/3, 1/3, 1/3. 3/3, 3/3, 3/3. Oh, looks like that would be the connection point. 2/3, 2/3, 2/3. It's right here. So by connecting the vertices, we have the location of the point of dilation. 1, 2, 3, 4, 5, 6 over 1, 2, 3, -4. So 6 to the right and then down -4. 6, -4 is the dilation point or point of dilation. And point of dilation is 6, -4. One more question. I have a test prep question. Quadrilateral LMNP was dilated to create quadrilateral. So right here, to create WXYZ means that WXYZ is my image. The image is smaller, so by elimination, what we need to expect is a scale factor less than 1. So it can't be 3, it can't be 2, it has to be half or 1/3. Which one is it? The half or 1/3? You try to answer, and we will talk about it in class.